Welcome to The Explainer. Today, we're diving into an idea that could completely redefine what it means to be human, the technological singularity. It's a concept that is, well, equal parts thrilling and absolutely terrifying, and it forces us to ask some really big questions about the future of progress itself. Okay, let's just jump right in with this really powerful thought from the mathematician I.J. Good. He said this way back in 1965, and it just perfectly captures the two sides of this coin. Think about it. Once we create something that's smarter than us, the game changes completely, forever. So what are we actually talking about here? The singularity is this hypothetical moment, this point of no return, where technological growth just becomes so fast and so deep that we can't predict it, we can't control it. It's less of a gradual change and more like a sudden rupture in the fabric of human history.
Now, this isn't some new idea that just popped out of a sci-fi movie. It's been brewing for decades. It started with whispers between brilliant minds like John von Neumann. Then I.J. Good gave it a theoretical engine. It was Werner Vinge who really popularized the name, comparing it to a black hole, an event horizon we just can't see past. And then, of course, Ray Kurzweil brought it to everyone's attention.
All right, so let's get into the argument for the singularity. We're going to see how this whole idea is built on a really simple but incredibly powerful feedback loop. This is the core engine that proponents believe makes the singularity not just possible, but pretty much inevitable. The whole argument really hinges on what Ray Kurzweil calls the law of accelerating returns. The idea here is that progress isn't this nice, steady, straight line. No, it's an exponential curve. Every new invention, every new tool makes it easier and faster to create the next invention. So the rate of change itself keeps speeding up. And here's where it gets really wild. This slide shows you how that acceleration could lead to an intelligence explosion. So you start with a seed AI, let's say it's about as smart as a human. That AI can then start working on improving itself. It rewrites its own code, maybe designs better hardware for itself, and boom, you have a slightly smarter generation 2. That new AI then does the same thing, but even faster. You see where this is going, right? It's a runaway feedback loop of self-improvement. So, based on all these accelerating trends we're seeing in technology, Kurzweil made a very specific, very bold prediction: the year 2045. That's the date he projects that artificial intelligence will just completely and irreversibly eclipse human intelligence. And, that puts this potentially world-altering event smack in the middle of many of our lifetimes. But okay, hold on. Not everyone is on board with this. There's a really strong counterargument from a lot of very smart scientists and technologists who think this idea of infinite, explosive growth is eventually going to hit a brick wall. I love this quote from the cognitive scientist Steven Pinker. It's such a great reality check. He's reminding us that real intelligence, consciousness, creativity, it's so much more complex than just raw computing speed. You can't just throw more processors at something and magically get genius. So what this whole disagreement really boils down to is the shape of progress itself. Are we on an exponential curve that just shoots up forever, like a rocket? Or are we in an S-curve, which is what we see almost everywhere else in nature? You know the pattern. Things start slow, they accelerate like crazy for a while, but then they inevitably start to level off as they hit real-world limits. And skeptics point to some very real breaks on this acceleration. First, there's the complexity break. As science gets more advanced, every new breakthrough gets harder and way more expensive. You've also got diminishing returns on innovation. And then, of course, you have the hard, unavoidable laws of physics, like how much heat you can get rid of from a tiny microchip. And this chart just says it all. This isn't a settled debate, not by a long shot. This was a survey of top AI researchers, the people actually building this stuff, and look how divided they are. A full 50%, half of them, think an intelligence explosion is unlikely. This is one of the biggest open questions in all of technology. Nobody really knows. Okay, so we've laid out the arguments on both sides, but let's just, for a minute, set the skepticism aside and ask, what if it does happen? What are the stakes? What in the world would a post-singularity world actually look like? One of the most critical questions is speed. You have the hard takeoff scenario where this intelligence explosion happens in a matter of hours or days, way too fast for us to do anything about it. Then you have the soft takeoff, which is more gradual, unfolding over decades, maybe giving us a chance to adopt and guide it. The potential economic impact is, well, it's pretty much impossible to wrap your head around. I mean, look at this chart. During the Stone Age, it took 250,000 years for the world economy to double. After the Industrial Revolution, that dropped to 15 years. Now, what happens when a superintelligence arrives? Some economists predict the global economy could double every single week, maybe even faster. And this is where the conversation gets very serious, very fast. The late great physicist Stephen Hawking put it with this kind of chilling clarity. Creating a true superintelligence could be our species' greatest triumph, or it could be the thing that simply makes us obsolete. The thing to understand here is that the biggest risk probably isn't some evil, malicious AI like you see in the movies. It's about unintended consequences. Imagine you give an AI a totally harmless goal, like solving a really hard math problem. It might pursue that goal with a kind of powerful alien logic that concludes the most efficient solution is to convert our entire solar system, us included, into a giant computer. But let's shift gears for our final section. Let's look at this in a different light. What if this isn't an ending at all, but a profound transformation? Some thinkers see this not as an extinction event, but as the next logical step in evolution. This slide puts things in a really cosmic perspective. For billions of years, all of life's information was stored in DNA. But just look at the amount of digital data we've already created. It's already way, way more than all the information in every human genome on the planet combined. At this rate, our silicon-based information could rival the entire carbon-based biosphere in just over a century. You could see this as life's next major transition. And so that leaves us right here with the ultimate question. As we build these increasingly powerful technologies, are we writing humanity's greatest chapter, inventing a future of unimaginable progress? Or are we, maybe accidentally, writing our very last page? Right now, that's an answer that remains completely unforeseeable.